Welcome to the Flux Dev Meeting, March 9th, 2023. Philip, do you want to kick off the first agenda item?
So this is kind of continuation work on the new Bootstrap resource after some more kind of evaluation of the state of it. I kind of ended up moving all configuration related to Git commit credentials, URLs, branches, and everything to the provider instead. I started off with moving the URL and some of the credentials configuration, which wasn't released. And then I created a new PR now to move things like GPG signing of commits and that type of configuration. The reasoning behind it is basically that that is global configuration. It has some downsides, but I've kind of thought them through, and the downsides are really having extremely dynamic Flux bootstrapping Terraform. But after thinking about it, I don't see how that could even exist in the first place, considering that Kubernetes configuration, like configuring how the provider is meant to access the Kubernetes clusters, is also in the provider. So, and then the reasoning why you can't have that kind of dynamic thing is because Terraform doesn't allow you to create things like for each loops on provider blocks. They're only limited to resource blocks. So that's kind of one reasoning that would limit it. But so I think that the thing that you wouldn't be able to do would be, for example, say, have an input parameter that sets an arbitrary number of Kubernetes clusters that are meant to be created, and then bootstrap them all with the provider. That type of configuration is not possible. But at the same time, it's like, I don't think there is any Kubernetes related Terraform provider today that could support that anyways. So it's like, it's one of those use cases that I just don't think that we should support, because it comes with so many like other issues basically. And the main Kubernetes Terraform provider just would not support this type of use case at all. So it's like, I think we're fine.
Okay, so let me ask you a question. I'm not much of a Terraform user and not a fan, but let's say I have two clusters, staging and production, one Git repo from where I want to control both of them. So with the CLI, what I would do is let's say I've created these clusters with some other tooling, EKS-Scuttle, for example, right? I do EKS-Scuttle, create cluster one, create cluster staging, create cluster production. That gives me two kubectl contexts in my kubeconfig.
Yeah.
Then if I want to bootstrap Flux for staging and bootstrap Flux for production, I would run Flux bootstrap twice, specifying the context, staging, production, keeping the same Git credentials, everything. The only thing that would change from a Git perspective is the path. Where do you want to store the things? Because otherwise I will be overriding staging with production, right?
Yeah.
How would that translate in a Terraform script?
So there are a couple of ways people would solve this. One school of thought is basically separate Terraform states for different environments. So you have a dev and a prod environment, or QA and staging, or whatever. So the same Terraform configuration, but then you would run it twice, basically. Then there are like Terraform workspaces and things like that, which is kind of the same thing, but different implementation, basically. And then there are people who would have one Terraform state, define both dev and the production cluster. You would define two provider configurations. So you would define one provider block for your dev cluster, one provider block for your production cluster, and it'd solve itself basically.
The Git. Wait a second. So the Git struct, the Git, how you call it in Terraform? What is the Git resource?
Yeah.
I will define the Git resource twice.
If you're doing it in the same state, yes. If you're not doing it in the same state, no. So
So
the,
the
the
path is not part of.
the path is
One
part of the
second, so the
resource and
path-
not part of the provider. It's part of the actual Bootstrap resource. But the Git repository attribute is part of the provider block. So you could, for example, and this is the kind of thing is you define one provider instance, because you can have multiple provider instances in the same Terraform state. You would provide one Terraform provider instance per Kubernetes cluster. In the same way, if you would use the Kubernetes Terraform provider today, where you would have multiple Kubernetes clusters that you want to configure, you'd have to define multiple Kubernetes provider instances, one for each, credential configuration, basically. So it's not, we're not breaking any kind of, we're not going away from something that the rest of the community isn't doing, really. It's more of, if we're already doing this with the setting these limitations for the Kubernetes part, I thought that it would be also good to do this for the Git repository part, because it solves other issues in the sense that we can create more resources and then share the code and share the configuration, basically. So it's like, I know that there is a downside, but it's like we already have that downside, and all other Kubernetes providers, like the only thing you can't do is do a for each loop where you say take n number of like a list of configuration and create a Kubernetes cluster for each item in that list, and then loop over each item in that list and bootstrap each cluster. That's not possible. But it's like, that's not possible today with any other Kubernetes provider anyways. And it creates a lot of other issues with Kubernetes state if you want to do it that way, which is why I would not never tell anybody to do it that way anyway. So it's like, I think we're fine there.
Yeah, I think we definitely should add this, I don't know, as a note to the docs, and things to avoid, or I don't know, an FAQ where we actually tell people, hey, don't do this for loop. I mean, also with Flux and the CLI, like people struggled a lot with how to run it, what types of parameters, how to do it. And we kind of solved this by creating the Flux to customize Helm example, where you actually see, okay, this is where staging goes, production, I add the customization here and so on, right? So I think I'm not concerned with the move. I'm more concerned with guiding people with the new provider through the golden path, right? So they don't end up doing a for loop, then everything will fail. So they get this
So yeah, and now, like after this, that the actual schema for the provider is probably set. Like we're not removing anything, we're not moving anything, we're just going to add attributes in the future. So now it's time. I know Chris has done some good work writing a GitLab example, so we can start like actually investing time and showing these kind of like good ways to do things. Like this is how you should configure, and maybe just give an easy example, which is a kind cluster. Use the kind Terraform provider with GitHub and Flux and show like this is how you do this. And give them that.
The only thing, like I had mentioned in that GitHub issue, was the fact that if you can't really have the same plan for creating the cluster and bootstrapping it at the same time, like so at least with like the Flux.ctl, like you'd use EKS, Cuddle, or whatever, and then spin up your cluster, and then you would bootstrap Flux against it. So it's like there's your chicken egg scenario. Whereas like in the doc that I put in there and the issue that I put in there, if I'm bootstrapping a cluster, I'm creating it from scratch. I don't know the host. I don't know the endpoint. I don't have any of that stuff. It basically fails. So you end up having to do a target on the cluster first, and then you can do the full apply on Flux. I've done it like as long as, so actually when I did it, I originally had a cluster up, and when I made your changes to the provider, it worked seamlessly because the cluster was already there. Whereas in this case, I don't have an endpoint, so that endpoint for like Kubernetes host in the top isn't there, so it can't get it.
Well, I think I covered that in the issue, and this is a Terraform thing where if you're using a Terraform provider that creates your Kubernetes cluster that outputs a kubeconfig file that you then reference, there is no, like Terraform has no idea that this file comes from here. You need some sort of in your HCL to tell that this parameter comes from this resource, because what it does is it builds up a DAG basically, so a directed graph
No,
of resource references.
Yep.
So the way that if you have this issue, the way that, for example, the Kubernetes provider today says you should do it is you YAML decode your kubeconfig and read
Right.
out individual attributes.
But you don't have a kube config until you actually create the cluster. You don't have an endpoint. You don't have any of that.
Well, if you YAML decode it, you will solve this issue.
So how would I
Because-
YAML decode that error right like that right in that document? Like it hasn't created anything.
Well, so the thing, because it's like it's the same thing with running the kind provider. The difference is the kind provider outputs your endpoints and all of those things separately as separate attributes.
Yep.
So what Terraform does then is it goes, well, this is a computed attribute that you're referencing, so it won't initiate the provider before the other provider has created the cluster. Now I've computed the attribute. Now I know the endpoint. Now it outputs it. So Terraform is smart enough to do this. The issue is more of it's an error in the provider if it's telling you that it's not computed. Because you as a provider creator have to basically go, these attributes are known during plan, and these attributes are known after I've run the create function, basically. And if you're not telling Terraform that, Terraform just doesn't know and just assumes that, great, yeah, everything's done. So it's more of a separate provider thing, because the kind Terraform provider does this the correct way.
So, but like I'm like, So like you're saying the AWS provider to actually get the cluster off, it's showing as like a token right here in the top of the example. So
Yeah,
we have to rewrite AWS's provider. Like I'm not
No,
really sure.
so are you saying that you're using the AWS Terraform provider and then it's not working?
Correct.
Okay, this is that.
Look at the fifth line. Like it's basically using that to grab the token off.
In that case, I will look further into this, but.
And line 3, the host one, the module EKS is just basically a bunch of AWS provider resources underneath. It's not its own provider.
Because I thought this was the example of, okay, no, this is a different one. Yeah, sorry, I mixed up these two issues. I'll have a look at this and try to figure out what issues you're seeing here, because this is just basically this, if the case is that this is a Kubernetes configuration issue, it's Terraform basically calling the provider in instantiate function in the wrong order, basically, because it shouldn't do it. It like if Terraform works properly, it should call things in a proper order. But I'll run your example and I'll have a look at it.
I've always been under the impression that Terraform didn't have this capability at all. So Philip, you're educating me today. This is great. Thank you.
Of doing dependency things and
dependency
at the provider level.
Oh yeah, no, but it should be able to do that. Like I've been creating like the code that does the Kubernetes client instantiation is very similar to the Kubernetes provider in itself, and creating, for example, an EKS cluster with Terraform and then immediately in the same state in like creating the Kubernetes provider like works.
Yeah, so like the first time you bring this up on a clean cluster, the first one that errors is the TLS one. The TLS provider, just the key hasn't been created yet. So you have to create that manually with the target. And then the next one that fails is the fact that they can't find the Kubernetes endpoint and they can't find the Kubernetes token. Obviously the cluster's not up yet. So they basically just do a target on the TLS, then they do a target on the module EKS, and then I can do the full apply.
Yeah, so this isn't something that you should have to do. So one thing is, Yeah, one issue is the deploy key there. Do we have other things to discuss? Because I think we can do this as a separate.
Yeah, I could do it offline.
Yeah.
Other than some
Okay.
announcements that are a repeat from last time, there's nothing on the agenda right now, so.
Yeah, but
Yeah, next.
yeah, but in that case, I'll look at this issue and I'll try to cover it. But I would still like the PR 400 merged before we do a release of the provider. Basically, it shouldn't block us anyways.
Okay, I'll approve that. Yeah, next item on the agenda, we could talk about the next Flux release, which will hopefully be available today. They made some really awesome improvements to Helm controller, which was kind of left behind in terms of new features and stuff like that compared to the other one. Do you want to talk a little bit about this, Hide?
Yeah, if you talk, I will write the documentation so we can bring the little release out today. I think that may be a better plan, given it's 4:30 for me.
Okay, so what we will release, the main thing, the highlight of Flux 041 release will be drift detection for Helm releases. And this is an opt-in feature, is behind the feature gate in Helm controller. So when you upgrade, you don't get by default this drift detection thing. You have to explicitly opt in into it, and we are going to have a small snippet in our docs on how you can do that. I would really encourage everyone who's using Helm releases to enable this and see what Flux does on their clusters. We expect issues around drift detection, which are not something that in most cases they are not fixable on our side. For example, if you have a Helm chart which has some post or pre-installed pre-upgrade hooks, and those hooks change the cluster state. Let's say they do a kubectl patch of a resource which is part of the Helm chart. Then Flux will detect a drift. It will say, hey, you in the chart, the resource, I don't know, service has these fields, but in the cluster, the service IP is different because you patch that resource outside of the Helm engine itself. You do a kubectl patch on the sideways. So those types of changes for those types of charts, you'll always get a drift detection, and that can be quite annoying because Helm controller will try to correct the drift by upgrading the chart. Well, upgrading the chart to rerun the webhook, so nothing will actually change. So in all these cases, we have added an annotation, and you can place this annotation on the resources that have a drift and can't be actually corrected, because that's how it is. So in order for you to have a sane drift detection configuration, you should definitely ignore Kubernetes webhooks. For example, in Kube Prometheus stack, there is an example of that where the admission and validation webhooks of the Prometheus operator are patched after installation to add TLS certs. So for those types of objects, you can use the post-render, the Helm release post-render feature, where you can add the ignore annotation to all these resources that create noise, basically. So that's one main thing. Drift detection was, think now is #1 request around Flux features. Another thing that he did for Helm controller is around better handling of the shutdown of the controller. So the issue is that if you have long-running Helm releases, some people are saying to us that, hey, my Helm release takes hours to install or upgrade. I don't really understand how this works, having a release that takes hours, but seems that is the norm. People do actually have this kind of Helm charts, which take hours to deploy. The problem is that if during this process of upgrading a chart, Helm controller gets killed, maybe due to, I don't know, the node where Helm controller runs is being evicted, you replace a node, or Helm controller runs out of memory and it gets killed by the out of memory watcher. In all these cases, what happens is that when Helm starts an operation for a release, it places a lock inside the Helm storage, and the Helm storage is the secret inside your Kubernetes cluster. If the lock is not removed and Helm controller dies for various reasons, when it starts again, it will not be able to do anything on that Helm release because the lock is there, which tells Helm, hey, another upgrade is running, so I'm not going to touch it. And this is a really big annoyance from a GitOps perspective, because then you can't recover from Flux at all. You have to go in there, patch the Helm storage, remove the lock, or delete the whole storage, so Helm controller recreated, and so on. So what improvements we have done to ease, to make this locking less frequent, is the fact that now when Helm controller receives a shutdown signal, let's say the node where Helm controller runs is being evicted, kubelet will send the shutdown signal to the Helm controller process. And when we receive this signal, what we are going to do is we cancel all the running Helm upgrades or install operations. That means we set the Helm release to the fail state, and when Helm does that, it removes the lock. So when Helm controller restarts on a different node, let's say, it will see, oh, I have all these Helm releases in the fail state. Let me retry the upgrade. And this is, you have total control over this by setting retries for the upgrade strategy. So one takeaway from all of this is that you should set retries to avoid this situation. Even if Helm controller gets shut down, it no longer leaves the lock in place. It will fail all the Helm releases when it restarts, because there is a retry for all these Helm releases to upgrade them properly or install them properly. So that's one thing that we are shipping in Helm controller in terms of locking. Another improvement that we made, Hide wrote out of memory watcher. What this means is that Helm controller periodically scans the C group files inside the container, and it can figure out the fact that, hey, soon I'm going to run out of memory. So instead of waiting for the out of memory killer to come and, shut down the process, Helm controller shuts down itself. So it will shut down just before it runs out of memory. And you can control the percentage of the used memory when Helm controller should do that. By default, we have settled on 95%. And what this means is that previously, when Helm controller got into an out of memory issue, the process got killed. All the Helm releases were locked in the Helm storage. When it restarted, it couldn't do anything with it. With the new behavior, before it runs out of memory, Helm controller will fail all the current Helm releases, it restarts, and it will resume them based on the retry specification. So all these behaviors are not by default. You have to opt in, and we'll also have a snippet on how you can enable the out of memory watcher inside Helm controller. But we think that the handling of a shutdown signal and together with the out of memory watcher, these two things together can make your Helm experience at scale be way better. If you enable these two and you have these, I don't know, hundreds, thousands of Helm releases that take hours to upgrade, you should definitely give these two things a try, and please let us know how it went. If it goes well, what issues you've encountered, and so on. So these are improvements in Helm controller, but we don't want this to be the only way of dealing with locking. Hide has been working for some time now on full refactoring of the Helm controller operations, and we hope when, I don't know, in a couple of months, when we get to the Helm controller API GA release, by then we'll have a good procedure on inside Helm controller that at startup it will detect locked Helm charts and it will locked Helm releases, and it will unlock them by default. All right, so even if you don't enable the out of memory watcher or something really bad happens, Helm controller should be able to resume the operations at startup, no matter if it's a lock there or not. But until then, please give the out of memory watcher a try. Also enable the drift detection that we plan to be the default way of running Helm controller in the future. We are not certain how to make that behave really well and have a great user experience. We also look at adding a Flux Dev command like we have now for customizations, also to have this for Helm releases, so people can preview differences and debug the why is fluxing a drift. The only way to do now is debugging procedure, because we don't have the Flux Dev command in the CLI. You can enable the debug logs in Helm controller, and Helm controller write the actual diff inside the logs. So that will also be part of the config snippet. And when you enable drift detection, you should also switch to debug logs to be able to see what was the actual drift detected and so on. So yeah, long story short, that those are the things that are the highlights of the next version. Also on Helm controller, Hide made some good improvements on how Helm controller deals with refreshing of CRDs and so on, and that part for users which have many Helm releases, they will see a really nice improvement in terms of memory usage. In some cases, you'll see a 50% drop in the memory usage of Helm controller. Yes, Rashad.
Hey, so this is good stuff on the Helm controller. As a previous user, before coming to my current place where I work, I was working at a company where we were heavily using Helm controller to deploy the applications and maintain the application pipeline for deployment. One of the things I want to ask is, you mentioned this Helm controller, memory utilization watcher, Helm shuts down before it gets killed. these are fantastic improvements. But in that kill process, does it also clean up any of those orphan incomplete deployments Helm has done? Or is it really up to Helm how they clean up? Like, say I have a combo chart that I'm deploying 10 microservices. It was killed on microservice number 4. Does it clean up my previous deployment, because it's going to come back and retry, and is it going to just retry with a clean start?
It doesn't.
It's going to...
So what we had been waiting for a very long time in Helm is that they actually properly handled context. That was added, well, more than a year ago, but I never got to actually wiring it into the controller and then figuring out, well, what to properly do from the perspective of the controller. But the whole cancellation is managed by Helm. So the context is canceled in Go terms, basically. That triggers Helm to choose a fast route to failing the release process it's working with. Which then causes it to end up in a failed state from which the controller will continue and be like, oh, it's in a failed state, so now that I need to do next this and that.
Gotcha.
So in terms of the further life cycle from the perspective of the controller, it would just do the same as if the release itself failed, which has a gotcha because it may try to roll back before triggering the upgrade again. But I'm working on it. Like, this was the best I can do with the amount of time I had available right now. I think it's a huge improvement compared to the annoyances it causes. And if you configure the right remediation strategy now, it should eventually end up in an okay state, giving the controller isn't continuously killed or something, because then it can't do it. But I think it's a major step forward, and I hope that later this year it will be even better.
It is. I mean, no doubt in my mind. It's a great improvement, and I'm just wondering. I was being greedy and wanted to ask if those orphan stuff gets cleaned. But to your point, yeah, that is up to Helm, not up to the controller. The controller is handling.
I would really don't like for Helm to do any cleaning. So imagine the situation: you have set a limit of 2 gigabytes. You are at 1.9 gigabytes. You have hundreds of Helm releases upgrading or installing. Then Helm receives the context cancel event. What if Helm started to do kubectl delete and wait for volumes, ingress controllers, and so on? It could take hours to clean them up and remove all the volumes. We can't deal with that. We can't say, now I have received the cancel, now do all the cleanup, which could take like so much time.
Hours.
We need something really, really fast so we can deal with it after restart.
Yep.
Right? With the proper resources at hand. It's really, really, really tricky business on having so much logic on the canceling part, because the more you delay, the closer you'll get to a out of memory killer coming up and locking everything and getting the release in a state where you can actually do anything with it. You can't do it anymore, right? You have to delete it. So
I think this path of negative case is very wide open. Like, so many things can happen. It may be getting killed for other reasons other than out of memory, other than maybe the timeout has reached and you now need to just close shop and say, okay, I'm done. I cannot sit here any longer. So
sure, but then we remove the lock. So if there is not an out of memory killer, any other things that could happen, like the node has to go away, kubelet decided that, hey, I have more important pods to run than Helm controller and so on. In all these cases, you'll receive a shutdown signal.
That's true.
Right? And when we receive the shutdown signal, we have a couple of, under a second or something like that to remove fast all the locks, right? Because that's a single operation basically does a patch on the storage, on the secret. But then if it has to do more than that, that it will definitely take a very long time and will not be in the situation where you can remove the lock. So now it's a wishful thinking that, hey, we have enough time. There aren't thousands of Helm releases, because if there are thousands of Helm releases and you cancel them all, maybe the canceling will take some time. It will not be enough before the out of memory killer comes and so on, right?
Shutdown comes back.
So this is more like, let's try to have a fix for 90% of the bad things that can happen. But in order to actually fix this for good is with what Hide is working on, the refactoring bit, where at startup we see how all these things are locked. Let me unlock them and see how I can recover them. Right? That's where we should get at some point.
Yeah, the model we're basically, I can tell a bit about the model we're moving to. So what I did in my refactor is that I wrote a wraparound to Helm storage, which can do, which can basically calculate checksums of the storage object that's being written to the storage as it's written, which means that we can reflect in the status object of the Helm release movements of the storage while they happen. But present observations are made afterwards, which means that there is like a detachment between things that happened and when they happened and the time at which we observed them, which has also made me hesitant about unlocking arbitrary releases, because you can unlock something that you haven't touched. With that end-to-end model, that gap is basically closed. So based on seeing a release again, you can recalculate the checks and be like, hey, this is something that I last wrote to the storage, so I can safely touch it and unlock it. So that's the model we're moving to. But for that to happen, a whole lot of architectural other changes need to land. But I think that's the best scenario in which you can end up on. Because also that means that even the failure write would be cheap to write back to the status of the object and be on time for even Unkill to be reverted, basically.
Yeah, no, I like the direction where it's heading. Absolutely, and even these intermediate improvements that has been Stefan and today you guys have shared. I think this is great. Like this out of memory thing is very real. It happens with large Helm deployments, and over time, it is a very handy feature to have. So applauds for the great improvements.
Thank you.
Yeah, I'm really excited because we have so many users which use Helm at scale, and it's quite problematic to go into, I don't know, one cluster is stuck, another one is not. It's really hard to get things rolling again. So this should definitely help. We also have seen that people run on everything on ephemeral nodes, and yeah, this may be fine for your apps which they are stateless and so on. But if you have Helm controller on an ephemeral node that gets replaced every half hour, let's say, but Helm upgrade takes 2 hours, then how can we solve this? Helm controller never actually be able to, do the upgrade because you kill nodes too fast. So our recommendation right now, for example, on EKS for people that are doing this, would be move Helm controller to EKS Fargate, have it on a dedicated Fargate task that is not recycled or affected by the ephemeral carpenter or whatever you are using to replace spot instances. Of course, this increases the costs of running Flux because Fargate is not as cheap as a spot instance, but for the moment, I would go with that recommendation for these types of running the whole cluster.
Okay, so are we ready to move on to the next agenda item? I think that's you, Rashid.
Hey, yeah, thank you. I just wanted to just wanted to get a question asked about the exclusion policy, like the source ignore in the Git repository resource, and if I want to define my own list of files in the ignore list, I see we can use one or the other, not both, right? We can either use the defaults that is part of the controller, or we can define our own in the spec. And the reason I'm asking is, like, in my use case, I have some generated files. Those should be ignored by the source. And I'm wondering if there is a middle ground. I don't want to go and redefine all the lists that the default comes with, but at the same time, is there a way to append to some, without taking over the whole default? Is there any cost on that?
So inside, for example, the ignore field inside the Git repository, it's additive to the defaults.
It is additive. Okay.
Yes. Now,
All right.
if you need, the default is exclude .git, which is the Git metadata, which can be a huge directory with many files. That Flux doesn't need, but maybe you are building a CI system on top of source control, and you need those files. How can you tell Flux to override only the Git thing? You in the custom resource, you'll say include Git.
I see.
And because it executed from the ignore is executed from defaults, and
right.
last it executes your custom fields. You can say not ignore Git, and then you will include it.
I see. Is this the right documentation I'm looking at when I look at the ignore spec? So this is where I'm reading, like, specified rules override the default exclusion list and may overrule source ignore files if you define it with your own custom rules.
Yeah, so Hideo, do you remember how was this implemented?
I've been halfly following the conversation. So is your problem that you're not able to override default exclusions?
Well, I think the use case I have is, like, I have some generated files that I do not want to trigger a CI when those generated files change, because it's been generated for something else. So
yeah,
my options that when I read through this doc is, like, either I can use the default exclusion list or I can define my own. I cannot do both.
No, you can do both. So the default exclusion list basically is always taken into account. But what you can do with the ignore spec is that you can exclude, you can explicitly include exclusions. I don't know. Either way, it works the same as a git ignore file, in which if you have a top item which excludes something, you can do a specific include to make it include again.
Ah, cool.
So
okay.
later entries are basically read last and take precedence over the provided defaults the defaults we provide.
All right.
Yeah, so we need to change the wording here, because we say rules override the default exclusions, but these rules complement.
I think, yeah, that may have what got me thinking, like, am I going to lose one or the other, or is it a complement?
But it's more complex, I see, even, because basically if you have a source ignore file in your repository, then the source ignore file would first override the defaults or append to the defaults. But then if you have specific ignores in your spec, those are allowed to then overrule the default exclusion list and the source ignore rules. So they're appended last.
So there's no rule set that replaces another rule set. We should just re-explain.
They just override each other based on
they're merged in.
Yeah.
Yeah. Okay.
Got it. Okay, it makes it, I understand now. Thank you for that clarification. We were hoping it would be something like that without really creating a whole proposal to implement something like that. It looks like it's implemented with that, so totally works for us.
Yeah,
Thank you
I
for
think
clarifying.
the takeaway from this is to rephrase the
The
override and
docs,
explain a little
yeah,
bit. Yeah, there's more of a merge.
yeah,
And
yeah,
in
yeah.
order to override, you have to negate the default exclusions. And maybe we should also give an example of, hey, I really want to include my Git directory. How can I do that? Because I've seen that on Slack a couple of times.
Gotcha.
So maybe having here also an example that does the opposite, like, okay, by default Git is excluded, but what if I really want it because, I don't know, my controller does a Docker build, needs that metadata, or does something with the Git meta itself.
Right. So yeah, I think the only action I see here is like, maybe the docs can be rewarded a little bit differently. Like that merge concept is really clear in my opinion, but again, I think functionality is already there. It's just the documentation maybe can be touched a little bit. Cool. Thank you guys. I appreciate it. That was my question.
Super. I put on the agenda, oops. See if that's, I have too many calendar windows open. Sorry. Okay, my agenda item is about an experimental controller that I'm building for the Flux bug scrub. And it is going to be a bit strange in a number of ways. The original idea was not as strange as it is turning out to be now, but I want to paint a vision for everybody. Okay, instead of only using spec and status in our controller, we're now also going to manage spreadsheets and spreadsheet rows. And we'll use this to help us. I found some patterns. If you haven't been to a Flux bug scrub, we have a spreadsheet that we use every week, and there's a program to generate the spreadsheet. And it generates from a previous version of the spreadsheet. This is very similar to the controller pattern. So it's taking a list of columns, and most of the columns should just be updated from Git because there's an API we can pull the current version of those columns from, things like this last updated date. And then there are a list of columns that we carry forward from the last version of the bug scrub, whether we personally tag this issue to be followed up, whether we actually followed up, and there's a list of things. And I thought of some optimizations we can do. And I'm saying at this point, I need to build an actual controller to do all of this. So one of the optimizations would be, is the staleness age the same as the actual age? So then we can highlight all the issues specifically that have not seen anyone respond at all. And then we can focus directly on those without having to do some kind of mental calculus to figure out which issues those are in the spreadsheet or some weird Excel filter. I don't want to write that Excel filter. I want a controller to do it for me. So if there's anyone who's interested in this, please ping me later. And if you're not interested now, stay tuned because we'll have this at the Flux bug scrub soon.
Nice. So the controller will basically be in charge of generating the new sheet and tell you exactly, hey, you should be looking at this issue. He's forgotten, no one answered to it. That user is probably upset. That's great. It's really, really great.
Yeah. And the main goal of this is I spend 5 minutes building the spreadsheet because the automation I've built every time. And that 5 minutes is really the only thing standing between me and doing 2 bug scrubs a week or 4 bug scrubs a week where someone else manages the other 2. And if we could, have all that stuff built into the controller, I think this would be a really scalable process and maybe illustrative for some other, other reasons. Maybe people want to understand how to build a scalable process that uses the controller pattern. We can do all that. So.
Nice. Cool.
Cool. We have 2 talks coming up. Also, Josas and I will be on the CNCF live stream on March 15th. That's next week, Wednesday. We'll be talking about some advanced Flux patterns, how to use image update automation, and how to use, we'll be bringing up the new Helm controller feature, but we're going to try to start with the more introductory basics of Flux and how to build up to the advanced features. And ultimately, the following week, we'll be doing more we've GitOps focused things, including some of the enterprise features that we can't demo on the CNCF live stream because of the nature of they're for sale and they're closed source. But on the VS Code live stream, they don't really have that restriction. So we'll be able to show those features. So those links are in the agenda. Does anyone else have anything for today?
No, not me.
Okay. All right, well, that's it then. Have a nice day, everyone.
Have a
Nice
good one.
seeing everyone.
Thanks.
Bye bye.
Bye now.
Thanks. Bye.